Good afternoon, students.
Good afternoon, sir.
Good afternoon. So in last class we started discussion on calculus. In that one we have discussed already limits concept and then continuity and differentiability, right? So limit means, so whenever the function, if it is not defined at any point, so we'll approach to that point, that what's that approaching value, whatever you will get, that one we call it as limit, right? And then continuity means if the function is defined at that point and if it is equals to the limit, then we call that the function is continuous. And then differentiability means there is what's that both left hand derivative and right hand derivative should exist, then we can say that the function is differentiable. And main results, important results based on differentiability are: every differentiable function is continuous, but converse need not be true. Best example for that one is, that is a function which is continuous but not differentiable is mod x function. So the mod x function is continuous at the point 0, but it is not differentiable at the point x equals 0. So that is the best example for the result. Every continuous function need not be differentiable. So in today's class, I'm going to discuss a partial differentiation. So anybody, can you tell me what's the difference between ordinary differentiation and partial differentiation? Vignesh, what's the difference?
Sir,
Yes. So how you will decide whether to differentiate function ordinary or partial derivative? For example, just I will take one function. Some f of x equals x cube. So for this function, will you apply ordinary derivative or partial derivative? Am I audible?
yes, sir.
So can you apply ordinary derivative for this function?
Partial, sir.
Partial derivative we can apply.
No, sir.
So the function f of x, so just to indicate it by some y. So now we have to decide, either we have to find out dy by dx or dou y by dou x. So this is the symbol dy by dx symbol. So this is indicating ordinary derivative. So and this dou y by dou x, so this is indicating partial derivative. We already studied both ordinary derivatives and partial derivatives in earlier classes. So in what's that +2 itself, we have studied ordinary derivative, and in first and second semester you have studied partial differentiation and then partial differential equation also. Right. So now for the function f of x equals x cube, what's the possibility? Either dy by dx we can find out, or dou y by dou x. Which one we can find out? Yes. Is it possible to find out the ordinary derivative for that one? Is it possible? Nobody knows the difference between ordinary derivative and partial derivative. Function is a function of how many variables? How many independent variables are there? Y equals x cube means?
1, sir.
Only one. Which is the independent variable? Which is the independent variable?
Yes, sir.
Which one? Y or X?
Independent is Y, sir. Dependent is X.
Independent is Y and dependent is X. Huh?
Yes, sir.
Okay. So now, if you have taken Y equals f of X means that is indicating that if you are changing the value of X, so based on value of X, Y will change, right? For example, just to consider one standard equation, which one? Y equals X squared. So what's the name of this curve? What's the name? Y equals X squared. If you are not remember this one, just Y square equals 4AX. Have you seen this curve earlier? Y square equals 4AX. Y square equals 4x. What's the name of that curve? That is a standard curve, right? What's the equation of the parabola? Anybody? What is the equation of the parabola? Y square equals 4x. Is it indicating? Is it indicates parabola or not? Vignesh. What is the name of that curve? Y square equals 4x.
It's standard form of parabola.
Parabola, right? So this is a parabola. So in this one, how will draw the curve? So just you will take x-axis, right? 1, 2, 3. So by putting x values, we will find out the corresponding y values. So here just to take a equals 1 for the simpler. For simplifying this one, just to take a equals 1. If you do a equals 1 means this will be 4x. If you put x equals 1, y will be 4 for x equals 1. For x equals 2, y will be equals to 8. For x equals 3, y will be equals to 4 into 3 means it will be 12. Correct. So at x equals 1, it will be 4 means it will be like this. Right. So similarly, you can find out the values left to y axis by putting x equals minus 1. If you put x equals minus 1, y will be equals to, once again, it will be minus 4 y square, right? So y square equals 4x means, so you can put the y values, then you will get the parabola. So here y square equals 4x means you will get the parabola like right side. Okay, so here whenever you consider y square equals 4ax, so 1 is the dependent variable which depends on, y is the dependent variable which depends on x, right? So here if you consider y equals f of x, y equals f of x, so that means, so y is depending on x. So y is depending on x. So this is the dependent variable and this y is the independent. This is the dependent variable. Y is dependent variable and x is the independent variable. So if you are keep on changing the x means the corresponding y values also will change. Right. So here, if you want to find out the rate of change of y, so which depends on what? X. So that means dy by dx will indicate rate of change of y with respect to x. So whenever you consider dy by dx, so this one, whatever numerator variable will be there, so this will be dependent variable and denominator variable will be independent variable. Is it clear now? Is it clear which is the dependent and which is the independent?
Yes, sir.
So now, so just I'll consider one more equation. Some z equals f of xy. So in this one, which is the dependent variable? Z equals f of xy. Which is the dependent variable?
Dependent is it. So
Yes.
Z is dependent, sir.
Z is dependent variable
X and Y is independent.
and x and y are
Independent.
independent variable. Right. So now if you want to find out the rate of change of z, you have to decide with respect to which variable you have to find out, either with respect to x or with respect to y. Right. So now if you are going to find out the rate of change of z with respect to x, rate of change of z with respect to x, so we have to denote it by dou z by dou x. So this will indicates the rate of change of z with respect to x. Since the function is depends on two variables x and y, we have to decide with respect to which variable you are going to find out the rate of change of the function z. So in case if you are going to find out with respect to y, means it will become dou z by dou y. So why we are denoting it by some what's that? So this is nothing but curly d symbol. Dou z by dou x. So whenever the function is depends on more than one variable, in that case you have to apply the partial differentiation. So this is nothing but what? Partial differentiation. Is it clear now? Is it clear?
Yes, sir.
If the function is depends on one variable, then you have to find out the ordinary derivative. In case if the function, any variable, if it depends on more than one variable, then you have to apply the partial differentiation. The rule for finding the partial differentiation is, whenever you are going to find out the partial derivative of z with respect to x, you have to treat another variable y as constant. And whenever you are going to find out the partial derivative of z with respect to y, you have to treat another variable x as constant. Just I will consider one problem. Some z equals x square y plus xy cube. So clearly this is a function of two variables x and y. So now if in case if you want to find out the dou z by dou x, means you have to consider, you have to treat y as constant. So then what's the derivative of x square y? What will be the derivative? What will be the derivative of x square y?
XY.
Not able to see.
Yes, tell loudly.
I'm unable to see.
What will be the derivative of x square y?
2xy plus y cube.
2xy. Right. So here y is constant. Whenever you are going to differentiate with respect to x, y is constant into derivative of x square will become 2x. Y into 2x. So here y cube is constant and derivative of x is 1. So that is 2xy plus y cube. So now differentiate the same function with respect to y. Dou z by dou y. So what will be the derivative? So now we have to treat x as constant. What's the derivative of this one?
Square 3 x square plus 3 xy square.
X square plus
That is why you got that error.
3
Not corrected.
Y square x.
y square x. Right. So this is the partial derivative of z with respect to y. So the rule is, so in case if you are going to differentiate with respect to y, you have to treat x as constant, remaining variable x as constant, and whenever you are going to differentiate with respect to x, you have to treat another variable y as constant. So this is the rule you have to follow while finding the partial derivative of any function. So now just I'll consider one more function. Some u equals how many dependent variables in this function?
3 independent.
3 independent variables.
One dependent, u is dependent variable, and remaining x, y, z are independent variables, right? So that means we can find out the partial derivative of dependent variable with respect to independent variable. So first one we can find out dou u by dou x. So that is the partial derivative of u with respect to x. What's the derivative of this one with respect to x? U
2x, y, z.
2x, y, z
yz cube.
plus yz plus yz cube, right? So find out dou u by dou y. Dou u by dou y.
X square z, xz, x square z plus xz
xz plus
plus 3z square x.
z square x.
XYZ square, sorry, sir.
xyz square, right?
Yes, sir.
So now dou u by dou z.
Sir, xz cube, sir.
xz. Which one?
Sir,
Yes.
dou
So
u
y
by
is
dou
1 also. So it's 3xz square.
Okay, 3xz square. Now, right.
z cube, sir, actually.
So, no, only xz cube then it will be.
It's z square, yeah.
Right. Now dou u by
Yes, sir.
dou z.
X square y plus xy plus 3z square xy.
X square y plus xy plus 3 xy z square. So like this we can find out the partial derivatives. So these are whatever we discussed till now. So these are the first order partial derivatives, right? So now in case if you want to find out the second order derivative,
Dou u square by dou x, dou y
just
square.
I consider u is a function of x, y. So then you can find out first order partial derivatives as there will be only two partial derivatives, either with respect to x or with respect to y. So now, in case if you want to find out the second order partial derivatives means you have to differentiate these two derivatives, first order derivatives with respect to x or y, right? So in case if you are differentiating this one, again with respect to x means what you will get? Dou square u by
Dou x square.
dou x square. So now if you differentiate dou u by dou x with respect to y, what you will get?
Same previous one, sir.
With respect to y. Yes.
Dou x
Dou x by dou square u by dou x into dou y.
You should write dou y dou x. You should not write dou x dou y because so dou square you are going to differentiate dou by dou x of dou by dou y of dou u by dou x. Right? You are going to differentiate the first order partial derivative dou u by dou x with respect to y. So that means you should write first y and then x. Okay. So now second term. Now differentiate this one again with respect to x and y. So here it will become dou square u by dou x dou y, and this one will become dou square u by dou y square. So how many second order derivatives we got? How many? How many second derivatives? You can't count also.
4, sir.
4, right? So there are 2 first order partial derivatives. There are 4 second order partial derivatives. In general, whenever the second order partial derivatives are continuous, in that case, this dou square u by dou y dou x will be equals to dou square u by dou x dou y. So whenever the function second order derivative is continuous, in that case only both partial derivatives dou square u by dou y dou x will be equals to dou square u by dou x dou y. Almost all whatever they will give problem. So almost all problems we will solve this, will satisfy this condition. That's why you can consider any one, either dou square u by dou y dou x or dou square u by dou x dou y. Is it clear?
Yes, sir.
Okay. So now based on these partial derivatives, questions will come based on Euler's theorem. Euler's theorem, or finding the total derivatives. Finding the total derivatives, or finding the Jacobian, are based on application part, that is finding maxima and minima. Maxima and minima. So these are the important concepts we have to study based on partial derivatives. So what it says, Euler's theorem, anybody? Because in first semester itself you have studied this Euler's theorem, right? What it says? If U is a homogeneous function of degree n, then x dou u by dou x plus y dou u by dou y
NU, sir, equal to NU.
Correct. Have you remembered this one?
Yes, sir. Yes, sir.
Okay. So whenever, if the function, if it depends on more than 2 variables, then it will become x dou u by dou x plus y dou u by dou y plus z dou u by dou z, which will be equals to nu. Right? So one more result based on this Euler's theorem. If U is not a homogeneous function, if U is not a homogeneous function, is not a homogeneous function, but f of U is homogeneous function, of degree n, then x dou u by dou x plus y dou u by dou y, which is equals to n into f of u by f dash of u. So this is the extension of Euler's theorem. You already studied this one in first semester itself. Just try to glance it. Okay, whenever the function is not homogeneous, so if it is f of u is homogeneous, then we can apply this extension of Euler's theorem. For example, some u equals sin inverse of x square plus y square. Is it homogeneous? Sin inverse of x square plus y square. Is it homogeneous? Homogeneous means all the powers should be same. Okay. So because of the sin inverse function, this function u is not homogeneous. If you shift this one to left hand side, the function will become sin u, which is equals to x square plus y square. So now x square plus y square. This is a homogeneous of degree 2. So that means we can apply this extension theorem. Then in place of x dou u by dou x plus y dou u by dou y, we can write 2 into f of u is sin u and derivative of sin u is cos u. That will become 2 tan u. Is it clear? So this is the statement of the theorem, extension of Euler's theorem. Based on that, in case if you want to find out the value of x dou u by dou x and y dou u by dou y, without finding the partial derivatives or without following the actual method, you can write the final answer, pick the final answer directly by applying the Euler's theorem or extension of Euler's theorem. Is it clear?
Yes, sir.
Okay. So next, total derivative. Total derivative means if u is a function of x, then du by dx. So this is nothing but the total derivative. Whenever the function is a function of one variable, the ordinary derivative will indicate the total derivative. But if you come into function of more than one variable, for example, u equals f of xy. So in this case, either you can find out with respect to x or with respect to y. And so we can take either x and y if both are functions of t, then we can find out du by dt as dou u by dou x into dx by dt plus dou u by dou y into dy by dt. So this is the formula for finding the total derivative whenever the function u is a function of two variables x and y are functions of single variable t. Then the total derivative is du by dt, which is given by this relation. So now the second condition is whenever u is a function of xy, xy, x is a function of some r and s, y is also a function of r and s. So here, once if you consider u, x and y are independent variable, but they are given that x and y again they are dependent variable which depends on r and s. So that means you have to apply chain rule. So here the total derivative will be given by dou u by dou x, dou u by dou r, which is equals to dou u by dou x into dou x by dou r plus dou u by dou y into dou y by dou r. So one
Sir,
more
your u is
dou u
dependent.
by dou
Sir.
s by just by replacing r by s, then you will get the one more derivative. So usually the important concepts based on this partial derivative, Jacobian and then application part. 70 to 80% they will ask based on the application part only, maxima, finding the maxima and minima. So that's why I'm not going to solve any problems based on these concepts, total derivative or Euler's theorem. So directly I'll move on to what's the term? Maxima and minima. Okay.
Okay, sir.
Maximum and minimum of a function are extreme values of a function. Maximum and minima are extreme values. So you studied in +2 for the function y equals f of x, whenever the function is a function of one variable, then maximum or minimum value you can find out by using the test. First you have to find out dy by dx, and then you have to equate it to 0. The root of this equation, root of dy by dx equals 0 are nothing but critical points After finding the critical points, just you have to find out second order derivative d square y by dx square. D square y by dx square. So based on the value of d square y by dx square, we will decide whether the function will attain its maximum or minimum. If it is greater than 0, then the function will attain its minimum. If it is less than 0, then the function will attain its maximum. If it is equals to 0, then you have to go through the first derivative test. So these are the three cases you should remember. The procedure for finding the maximum or minimum of any function of single variable is first you have to find out the first order derivative, and then you have to equate it to 0. By equating the first order derivative to 0, you have to find out the root of that equation. After finding the root of the equation, so just you have to find out the second order derivative, and in the second derivative you have to substitute the value. Whatever you got the critical points, that value you have to substitute in the second order derivative. So once you substitute the value, we will come to know the value of the function d square y by dx square. So if it is greater than 0, then at that point, at that critical point, the function will attain its minimum. If it is less than 0, then it will attain its maximum. If it is equals to 0, then you have to apply the first derivative test. So based on first two cases, maximum or minimum for less than 0, greater than 0, based on that, those two conditions only problems will be there. Is it clear, this step or procedure?
Yes, sir.
Okay, so just
Yes,
to
sir.
try to remember this one.
Yes, sir.
So because I'm going to solve a few problems based on this method. So alternatively, I'll explain what's the condition for partial differentiation also. After that, I'll move on to problems. Maximum and minimum for partial derivatives. Whenever the function of two variables, maxima and minima of function of two variables. Function of two variables. So in this one, so just I'll consider some u is a function of xy. So in this case, we can find out dou u by dou x and dou u by dou y. So here also you have to equate these two equations to 0, and you have to find out x and y value. Find x and y by using the equation dou u by dou x equals 0 and dou u by dou y equals 0. After that, you have to find out the second order derivative, dou square u by dou x square, dou square u by dou x dou y, dou square u by dou y square. So just I will take this one as A, and second one as B, and third one as C. So after finding the ABC values, just you have to find out AC minus B square. If it is greater than 0, then you have to go through the two cases. One is either A greater than 0 or A less than 0. We have to check if it is AC minus B square greater than 0, then you have to check the value of A. Either it is greater than 0 or less than 0. If it is A greater than 0, then function attains its minimum. If A less than 0, then the function attains its maximum. So now AC minus B square is less than 0, then the point will become saddle point. AC minus B square, if it is equal to 0, then it requires further investigation. So based on this, we can't compute whether it will attain its maximum or minimum by using this derivative test. You have to go through the another test to find out the nature of that, what's that value of the function, whether it will attain its maximum or minimum at that critical points. So this is the procedure for finding the maximum or minimum of a function whenever the function is a function of two variable. Is it clear?
Yes, sir.
So just for the for solving the problem, you should remember this thing. Before that, you should find out the first derivative as well as second derivative. A minute, I will open the PDF. Is it visible? Image?
Yes, sir.
Yes, sir.
Just to see the first problem, f of xy equals 2x square plus 2xy minus y cube. So then it has only one stationary point at 0, 0, two stationary point at 0, 0 and 1 by 6 comma minus 1 by 3, two stationary point at 0, 0 and minus 1, 1, and there is no stationary point. So, so these are the questions, few questions. So just I picked from the previous year papers, GATE exam papers. So from those previous year papers, I picked these questions. So just you try to solve the first one, all of you. First question. So because you know the method, stationary points are nothing but roots of the first order derivative. So by seeing the options, you will come to know 0, 0, anyway it will be one of the stationary point. Only you have to check either it will be having two stationary point or only one point. If it is having two stationary point, then you have to find out the second stationary point also. I'll have to try this problem. Once if you get the answer, let me know. Anybody got the answer? Just to note down the function 2x square plus 2xy minus y cube. F of 1 minute. F of xy equals 2x square plus 2xy minus y cube. Is it right function?
Yes, sir.
Okay, so now we have to find out the stationary points. So that means you have to find out dou f by dou x. What's the partial derivative of f with respect to x? What's the partial derivative?
Minus y cube. 4x
4x. Next,
2y
2y.
minus y cube
Next,
minus y cube.
minus y cube as it is.
I think
Constant a
0.
0. So that means y cube is constant, right? So
Then 0.
this constant means the derivative of y cube will become
0.
0. So 4x plus 2y. So now find out dou f by dou y. First term, the derivative of first term, derivative of 2x square. What's the derivative of 2x square with respect to y?
4x.
With respect to y.
Sorry, sir.
Yes. What's the value with respect to y? Derivative of 2x square with respect to y. There is no y variable, right? There is no y variable means it will be constant. The derivative of constant is
0.
0. The first term will become 0. So now we have to find out the partial derivative of the remaining two terms. So remaining terms are the derivative of 2xy. What's the derivative of 2xy?
2x.
2x minus 3y square. Right. So now we have to find out the value of x and y by using these two equations by equating to 0. 4x plus 2y equals 0 means it implies x equals minus y by 2. Is it right? From the first equation, we are getting the relation for x in terms of y as x equals minus y by 2. Our aim is to find out the value of x and y. So that's why we have to substitute that x value in another equation. So just to substitute in this equation, 2 into minus y by 2 minus 3y square, which is equals to 0. So this implies 2 will get cancelled, y plus 3y square, which is equals to 0. So now y you can take it out, then it will become 1 plus 3y, which is equals to 0. Either y equals to 0 or 1 plus 3y equals to 0. So this implies y equals minus 1 by 3. So now you use this value in the equation x equals minus y by 2. If you put y equals 0, for y equals 0, x also equals to 0, right? Now for y equals minus 1 by 3, x will be equals to minus minus will become plus. So 1 by 3 means it will be 1 by 6. Therefore, the stationary points are 0, 0 and 1 by 6, minus 1 by 3. Understood? 0, 0 and 1 by 6, minus 1 by 3 are the stationary points of the given function. Is it clear?
Yes, sir.
So then we can check which option is correct. Which is the right option?
B.
B is the right option. So now the same procedure you apply for the second problem, the maximum value of this one. So but you have to find out the maximum value, right? So this one is asked in was asked in which one? ECE GATE exam 2014. So here you have to find out the double derivatives also. After concluding at which point the function attains its maximum, at that point you have to find out the maximum value also.
Okay.
Just to try this one, second problem. Otherwise, I will do this problem. Next one you can do it, okay? If you are ready to try, you try. Otherwise, I will do. Will you try or I have to do?
We'll try, sir.
What you are telling, Kirtana?
We will try doing it, sir.
Okay, okay. Now if you note down the function 2x cube minus 9x square plus 12x minus 3. Anybody got the solution?
Sir, you solved, sir. We will see.
Okay. So just to help me to note down the function. What is the function?
F of x is equals to 2x cube
F of x equals 2x cube
minus 9x square
minus 9x square
plus 12x
plus
12x
12x.
minus 3.
So this is a function of how many variables?
One variable.
Only one variable, right? So that means you have to apply ordinary derivative test. No need to apply the partial derivative test. So since the function is function of one variable, since function is function of one variable, we have to go through the ordinary derivative test. Ordinary derivative test. So now first you have to find out the df by dx. df by dx, which will become
6x square minus
3 into 2 means it will be 6x square minus 9 into x square means the derivative of x square is 2x. So it will become 18x plus 12. So now we have to equate it to 0. What's the, so 6, take 6 common out into x square minus 3x plus 2, which is equal to 0. Since 6 is constant, we can cross multiply, then it will become x square minus 3x plus 2 equals 0. So now what are the roots of this equation?
2 and 1.
The roots? Yes.
1 and
Right? So now we have to find out the d square f by dx square. D square f by dx square. The derivative of df with respect to x means it will become 12x
minus 18.
minus 18. So now put x equals 1 and x equals to d square f by dx square at x equals 1. At x equals 1, what's the value? Minus 6. And at x equals 2, the same function, it will be, if you put 2 means it will be 12 6 12 2 24 minus 18 means it will become 6. So here itself you can't conclude which will become the maximum value. You have to find out at the interval end points. So just you have to find out. So what's this? Minus 6 less than 0 and 6 greater than 0. So that means according to the differentiation test, ordinary derivative test, the function will attain its maximum at the point 1, right? At the point 1, at x equals 2, it will attain its minimum. So now find out the value of the function. Find out the value of the function by putting x equals 1 in the given function. If you put x equals 1, f of 1 will become 2 into x cube, that is 2 minus 9 plus 12 minus 3, which will be equals to 2 minus 9 is minus 7 plus 12 is 5 minus 3 means it will be 2, right?
Yes, sir.
So here itself you can't conclude this will become the maximum value of the function. So because they are given the interval 0 to 3, also you have to find out the value of the function at the end points. So that is, you have to find out f of 0. If you put x equals 0 in the given function, the value of the function will become minus 3. And if you put x equals 3, then it will become f of 3 will be equals to 2 into 27 minus 9 into 9 plus 12 into 3 minus 3. So which is equals to 54 minus 81 plus 36 minus 3. So 54, 36 means how much it will become?
6, sir, total.
90 minus 84, right? Which is equals to 6. So now which is the maximum value? So f of 1 equals 2, we got it, right? So this is the 2. So and f of 3 is 6. So out of these three values, 2 minus 3 and 6. Out of these three values, 6 is the maximum. So that means the function, maximum value of the function in the interval 0 to 3 is 6. Is it clear? Is it clear?
Yes, sir.
Since why we have to find out the value of the function even at the end points also means the what's that derivative test will not applicable for the end points. So that's why even if it is attaining its maximum at the end points, it will not applicable. So we will not get that point as stationary point. What's that critical point? So that's why you have to find out the value of the function even at the end points also.
Okay, sir.
So next problem. So then we can check first what's the answer for that one. So 6 means first is the A is the right option, right? So they may confuse. So if you checked what's that, if you found the value at the 1 means you'll get 2. If you select this option C as 2 means you will get the what's that? So your answer will be wrong. Okay, so you have to find out even you have to find out after finding the maximum value by finding the stationary points. Also, you have to find out the value of the function even at the end points also. Okay. So now will you try this again? Which one? Third one? Will you try?
Yes, sir.
Okay. Shreya, is it your first class? Shreya,
Yes, sir. Yes, sir.
how you come to know gate
Uh,
classes are going on?
So actually, I wanted to prepare for GATE since
Okay.
starting. So I went to library for borrowing few reference books. Actually, they told they won't give. And then I asked, someone borrowed 2019 book. They said one teacher borrowed. And then I asked, is there any GATE groups in our college? They told IS department HOD knows. So they gave me the
Okay.
IS department HOD contact number. So I called ma'am, and then ma'am was like, I'll add you to the group and you can listen to the classes. So today only I got added, sir.
Okay, fine. Actually, whatever books are there, they kept in library. That books will be only for reference.
Yes, sir. Yes, sir.
Yeah, they
But
will
but
not.
they gave because it's during lockdown they gave, sir. They actually gave. Except 2020, they gave the other books, sir.
Okay. I have given few more books list for the GATE exam. I don't know whether they purchased or not. So you have to collect so in case if you want to prepare for GATE means you have to collect at least some previous 10 years papers. Then only you will come to know how they will ask the questions and what and all concepts are important.
Yes, sir. I collected, sir. I have.
Yeah.
Yes.
Okay. You should try the third one, all of you. So the same ordinary derivative test only you have to apply. Since the function is a function of one variable. So by seeing the function, you have to decide whether you have to go through the partial derivative test or ordinary derivative test by checking how many independent variables are there. If only one independent variable, then you have to go through the ordinary derivative test. In case if they are having more than one independent variable, then you can go through the partial derivative test. In case if it is more than 2, means you don't know any test to find out the maxima or minima. You know methods only for up to function of 2 variables. After that, we don't know exact method. So what's the derivative test methods? We don't know. So other methods we can, by using other methods, you can find out just by plotting the graph like that. So the same procedure you apply for the third one also, whatever we applied for the second one. So here the interval endpoints are 0 and infinity. First you find out the stationary point or critical points. After finding the critical points, just to find out the second order derivative. In that one you put stationary points and you check whether it will attain its maximum or minimum. So after coming to know at which point the function will attain its maximum, just to find out the value of the function at that maximum point, and then find out the value of the function even at the end point 0 and infinity also. So then compare all the values and conclude which is the maximum value.
Excuse me, sir.
Yes.
Sir, they said that there's a YouTube channel where they upload all the videos.
PR department, they are going to upload. I don't know. For actually first class link they sent to me. After that, they didn't send me. I'll ask, I'll inquire and tell you, okay?
Okay, sir. Thank you, sir.
Vignesh, you are weak in differentiation, na? Vignesh? Vignesh, am I audible? So just to tell me your numbers for attendance from civil, from EC, anybody?
Sucharita, sir.
Sucharita Y, right?
Yes, sir.
Last week absent, huh?
Yes, sir.
Anybody else?
Varun sir.
Varun. So how many classes, man? This is the 4th class.
Yes sir.
Break, huh?
Sure.
Take long break.
Yes sir.
Okay, anybody else from EC? Next from Tribali? No guys from Tribali. From civil?
Kirtana, sir.
Pavan sir.
Pavan. Kirtana and Pawan.
17 CV 122, sir.
122. Next from mechanical. Mechanical, anybody? Anybody from CS?
Sir Shreya.
Shreya, I think for you not needed this one. Attendance anyway, I'll write, okay? 1 NH, 19 CS.
167, sir.
You are in third semester now.
Yes, sir.
Earlier you were in which section?
C section, sir. D section, sir.
D, okay. Anybody got the answer? Nobody is getting answer. What's the derivative of f of x? F of x equals x e raised to minus x, right?
Minus x.
This one df by dx. Yes.
Sir, it's given x into e power x, no, sir? Like plus x.
X e power x, huh?
Yes, sir.
1 minute, I'll check. No, x e raised to minus x it is.
Okay, sir. I copied it wrong. Sorry, sir.
Okay.
Minus x. Oh my god, everything is wrong.
X e raised to minus x, then you have to take the UV rule. X into, what's the derivative of e raised to minus x? Minus e raised to minus x plus e power minus x into derivative of x is 1. So that means it will become 1 minus x, right, into e raised to minus x. So now you equate this one to 0. So either e power minus x equals to 0. Is it possible? E power minus x, is it will be 0? At which point the exponential function will become 0?
Minus 1.
Minus 1 now.
Wait, that is infinity.
Definitely this will be non-zero. Only possibility is 1 minus x will be equals to 0. The function, exponential function, will be 0 at the point infinity, right? E power minus infinity will be 0. Okay. At the minus infinity it will be 0. So that means, so no need to consider infinite point. So just you can consider 1 minus x equals 0. That implies x equals 1. So this is the required critical point. So now find out the d square f by dx square. D square f by dx square. So which is equals to, otherwise you can, what's that, since only one stationary point is there, you can find out value of the function here itself. That's also fine only. So now if you find the, what's that, second order derivative, so it will become 1 minus x into derivative of e raised to minus x will become, once again it will become minus e raised to minus x plus e raised to minus x minus sign is there, 1 minus x into e raised to minus x, right? E raised to minus x into derivative of minus x is 1, which is equals to 1 minus x into minus means it will become minus 1 plus x minus 1 into e raised to minus x, which is equals to minus 2 plus x into e raised to minus x, which is equals to, so now you put x equals 1, then it will become minus e raised to minus 1. That is nothing but minus 1 by e, which is less than 0. So less than 0 means the function will attain its maximum. So now find out f of 1. F of 1 equals 1 into e raised to minus 1. So that is nothing but 1 by e. So now find out at the point, at the end points, f of 0 equals to 0, f of infinity. F of infinity means e power minus infinity. E power minus infinity means this also will be 0. The maximum value will become 1 by e is the maximum value. Is it clear? Is it clear, students?
Yes, sir.
So just I close this one. So we can check which is the right option. Which one? Third one, right? E raised to minus 1. So first A option is the right option. The same thing for fourth one also. The minimum value of the function f of x equals x cube minus 3x square minus 24x plus 100. In the interval, closed interval minus 3 comma 3 is, you have to find out the minimum value. The same procedure you have to apply. So just to try this problem. So then I'll, last one is directly you can answer. I'll explain that one, how to select the right option for the last one. This one you try, at least you should get right option for this one. The minimum value of the function. It is a polynomial in one variable. So one variable means, once again you have to go through the ordinary derivative test only. Pawan, are you getting civil, Pawan?
Yes, sir.
Actually, civil and mechanical are based on mathematics. Mathematics part, they will ask some little bit easy questions compared to EC and Triple E. Shreya, you put effort on the modules. What's that? Linear algebra and then probability, sampling theory.
Okay, sir.
Concentrate more on those modules.
Yes, sir.
I think for you, CS, there will be no integral calculus. A multiple integral calculus will not be there for you guys.
Okay, sir.
Find out the critical point. After finding the critical point, just to check at those critical points, is it attains its maximum or minimum? So at which points the function attains its minimum, at that point only you have to find out the value of the function. And at the, in case if you are getting some one critical point where the function attains its maximum, means no need to find out the value of that function at that point, because we are going to find out minimum value. Once if you get the answer, let me know.
$28, sir.
28.
B
B
option.
is the option.
Yes, sir. 28.
Yeah, correct. Others? Varun? Sucharita?
Yes, sir.
What's the answer?
Sir, I'm doing, sir.
Okay.
I think 28.
Yes, 28 only we are getting.
Yeah. Okay, so just to try this one, even you can directly answer this one. So just to find out the first derivative, you will get the what's that critical point. Even they told at the point x equals 0, you have to conclude whether it will arrange its maximum or minimum, or both local maximum and minimum, or neither local maximum nor local minimum. So local maximum means d square y by dx square at the point x equals 0, it should be less than 0. Local minimum means d square y by dx square at the point x equals 0, it should be greater than 0. Both local maximum and minimum means there will be no possibility of getting like that. What is it, local maximum and local minimum? So neither local maximum nor local minimum means it will not attain its maximum or minimum at that point x equals 0. So those who completed fourth one, just to try the fifth one, find out.
Sir, it will be both local maximum and minimum, no, sir?
So you got d square y by dx square equals 0, wow.
Yes, sir, but
If it is equals to 0, then it will not attain its maximum or minimum. Okay.
yes, sir.
So then D will be the right option.
Neither local maximum nor not.
Yeah, neither local maximum nor local minimum. Is it clear? Last question.
Yes, sir. Next question, sir.
I'll move on to next concept, integral calculus. In integral calculus, so with respect to one variable and then with respect to more than one variable, that is multiple integral calculus you are going to study. So for the any question based on integral calculus, you should thorough with the first point is you should thorough with the integration formulas. Even if you are not able to remember all the formulas, you should remember some standard formulas for solving the any integral. Okay, so next one is properties of definite integrals. So these are very important, properties of definite integrals. So almost all questions will be based on these properties of definite integrals. After that, they may ask application part, finding the area. So that will be easy only in case if you know how to solve the evaluate the integration. Integral means so you can find out the area easily. So first thing is integration formula, try to remember. After that, so some few methods for evaluating the integral. So that is especially substitution method. Substitution method. For example, integration of sin x we know, right? What is the integration of sin x? What's the integration of sin x? Cos x, right?
Minus cos x.
Minus cos x, exactly. Minus cos x plus c. So now in case if you are having function sin of x square into x dx, what will be the integration of this one? Integration of sin of x square into x dx. Yes, Raya?
Yes, sir. Like
What's the integration of sin of x square into x dx?
Sin square x. Sin x
Sin?
square can be written as 1 minus cos square.
1 minus sin square is there means you can write 1 minus cos square x. Here sin x square is there, right?
That's see, it is equal to a variable we'll take, sir, like a constant or something.
Which one you will take?
Sin x square is equals to t.
Sin x square itself you will take t. Okay, sin x square will take t. After that, what you will do?
No, so we should take
No, sir.
1 minus
Only
cos
x square.
square, cos x square, we should take it as t.
No, x square we should take as t, sir.
Yeah, x square you should take t, right?
Take as t. Sir.
Okay,
So
so Shreya, just to see here, there is no function sin square x. In case if it is
Yes, sir. Yes, sir. I got it.
then you can take like that. Okay.
Yes,
So
sir.
even sin square x is also there. You should not take 1 minus cos square x, because if you took 1 minus cos square x means once again you will not get the value of cos square x, right? So instead of taking 1 minus cos square x, you can take whenever sin square x is there, you can take 1 minus cos 2x by 2. Then you know the what's the formula of cos 2x as well as integration of constant also, you can solve it, right? So in this problem, you have to take x square as t, substitution x square equals t. If you took x square equals t, you have to
X is equal to dt by 2.
2x dx equals t, dt, right?
Yes, sir. So
now in place of x dx, we can write x dx
dt by 2.
by 2. So now you substitute this one. So it will become sin t into dt by 2. Now 1 by 2 is constant, we can take it out. 1 by 2 into integration of sin t is minus
Cos t.
So which will become 1 by 2 into, now resubstitute the value of t, it will become minus cos x square. So this is the required integral. So this method is nothing but substitution method. Almost any integral, if they ask, if they are going to ask for some what's that competitive exams means, almost they will be based on substitution method, one thing. And one more thing is, so based on properties of definite integral, right? So what's the definite integral? So I'm not going through the formulas, just to collect the formula list and try to remember some few important one. What's the integration of sin x and polynomial, and integration of inverse trigonometric, and some few important one you just to try to remember. Okay. So now I'll move on to definite integral. So what's the definite integral?
The limit 0 to.
1 minute, Vignesh. Yes, tell me.
Sir, a limit given to the integral, sir.
Limit
Given to the integrals like 0 to infinity, like that, sir.
Okay, first I'll write integral. Integral can be divided into two parts. One is definite integral, one more is indefinite integral. So indefinite integral means there should not be limits. So if you are going to integrate any function means, so for example, integration of sin x, so here there is no limits. So this is nothing but what? Indefinite integral. Whenever the indefinite integral is there, so for the answer you will add integration constant. For this one, minus cos x plus c, right? So we used to add integrating constant whenever we are going to integrate the indefinite integral. Definite integral means if you are going to integrate the integrand in between the some limits or in some region, then
Limit.
integral as definite integral. So for example, a to b, integration a to b f of x dx, right? So in between the limits, if you are going to integrate means, then we call that one as definite integral. So further, these definite integrals are classified into, one is proper definite integral, and one more improper definite integral. Improper definite integral. So what's the definite proper definite integral? When we say that the definite integral is proper, yes? Any idea about proper and improper?
So it continues, sir, like
Which one is continuous?
a proper definite, sir.
No, what it should be continuous, either integrand or value of the integral. Just
Integrals, sir.
an example, okay? Integral over 0 to 1 by x dx. Is it proper or improper? Definitely it is proper definite integral, right?
Yes, sir.
Definite integral. Now you tell me whether it is a proper definite integral or improper definite integral.
Proper, I think so, sir.
Yes.
Proper definite integrals.
Okay, what is the integration of 1 by x square? 1 by x?
Log, sir.
Yes, minus
1 minus x square. Yes, sir. Yes, sir. Sorry.
integration of 1 by x is minus 1 by x square, right? Not minus 1 by x square, it is log x, right?
So it's log x plus
Integration of 1 by
2a
x is what?
log x.
Log x. Log x in between the limits 0 to 1, which is equals to log 1 minus log 0. What's the value of log 1?
0.
0.
What's the value of log 0?
1.
Yes? 1.
1.
Log 0 1 na?
1.
Is it 1 log 0?
Infinite, sir.
Infinite. So that means it's not defined. It will be infinite, it's not defined. So that means whenever the limits, so either A or B, so A or B, if they are infinite, then it will become improper definite integral, or the value of the integral A to B f of x dx, if it is infinity, then also it will become improper definite integral. So in other cases, if the value of the integral, if it is finite, then it will be proper definite integral, or if the limits are finite, then also it will become proper definite integral. Is it clear?
Yes, sir.
Yes, sir.
Okay. So now properties of definite integrals. Properties of definite integrals. Properties of definite integrals. First one is integral over a to b f of x dx. So if you are changing the path of the integration means you have to multiply by negative sign. It will become minus b to a f of x dx. If you are changing the path of the integration, then you have to multiply the integral by negative sign. So next one, second one is integration from a to b f of x dx. So if you are changing, if you are splitting the path means you can write this one as a to c f of x dx plus c to b f of x dx. And one more thing you keep it in your mind, whenever you integrate the definite integral, then you should not write the integration constant. So just you have to write the value of that function integral. So this is the second property. Third property is very important one. Integration from minus a to a f of x dx. Anybody? Have you remembered this property? So usually problems will be based on this property only. Integral over minus.
Yes, sir. It's 0. For odd, we'll have 0, and even we'll have 2 into integration of 0 to a f of x dx.
When it will be 2 times 0 to f of a, 0 to a f of x?
It will be when it's even condition.
When it is even condition. Whenever it is odd?
0, sir.
It will be 0. Right, exactly. It will be 0 when f of x is odd. It will be 2 times integral over 0 to a f of x dx when f of x is even, right? So you should know how to check whether the function is even or odd. So just you have to check the value of what's the function, whether it is even or odd. Just you have to replace x by minus x. If it is equals to f of x, then it will be even function. So this is the condition for even. So if it is equals to f of minus x equals to minus f of x, then we call that the function is R function. Is it clear?
Yes, sir.
Yes, sir.
Okay, so next fourth property is fourth one, integral over 0 to 2a, 0 to a, not 0 to 2a, 0 to a f of x dx equals 0 to a f of a minus x dx. Okay, this is also one more important property we used to solve whenever we are going to solve the problems based on definite integral. We used to apply this property also. Integral over 0 to a f of x dx is 0 to a f of a minus x dx. Is it clear?
Yes, sir.
Okay, so at least this much if you remember means you can solve the questions based on what's that integral calculus, and multiple integral calculus means with respect to what's that there are some rules for evaluating the double and triple integrals. So the rules you are already studied in first semester itself, so just to go through those rules. So almost all problems will be based on these definite integrals only, almost all will be there. So in case if they ask for multiple integral means you should be, if you remembered what's that rules means, that will be enough for solving the multiple integrals like double and triple integrals. I think already 4:48. Okay, I'll stop at this stage and I'll continue in next week. Okay.
Next week.
Yes, sir.
Okay, students, thank you.
Thank you, sir.
Thank you all.
Thank you,
Thank you,
sir.
sir.